in his wacky. Alright. So implicit differentiation. So let's say I gave you something like this. X squared plus y squared plus 2y minus 2x equals 8. And I told you to take the derivative of it. The problem is you cannot get y by itself. So you could get like these two on one side, but then to get that y squared into a y, you have to take the square root. And if you take the square root of that, you have to take the square root of that, and then you'd have the square root of y, and then that's a pain. So you'd square that to fix it, but then that would be squared, and you're like in this loop where you can't fix it. So
just flip it over. Now I feel like I get all my notes because I missed it.
We're all gonna watch.
sorry, Steven. Did you just throw your snot in the recycling bin?
You did!
Oh, there's a difference? I never
Oh my
knew
God.
there was a difference.
Dave, you're just gonna leave it in there?
Oh,
Nobody
yeah,
else is
actually,
touching
What do you think? I'm gonna get it?
I thought it was just gonna stay there.
We're very sorry, Steven.
Steven, I apologize profusely.
Steven wants to.
So, alright. So,
Steven, stop commenting.
implicit, it kind of means like implied, right? So there's like, we're going to take the derivative in a different way. So even though I'm never going to know what the original equation was, like I'm never going to be able to say, well, y equals this, I can still find the derivative of it. And it's like a chain rule thing. We're not going to get too in-depth into the details, but you kind of imagine that you could solve for y, and then that y is represented by this. So whatever y equals, even though we can't technically say y equals this, we kind of assume we can, and the y is within that y and that y. And that probably makes no sense. But let me just go through the process, and I think you'll see. The process is really easy. Understanding it is tough. So what we're going to do is we're going to take the derivative. I'm going to write like the step, like the note for the step, and then the step, the note for the step, and then the step, the note. Does that make sense? So we're going to take the derivative of everything. But if you take the derivative of a y, multiplied by dy over dx. And what does dy over dx mean? It means derivative. So we're kind of assuming there's a y in there. And then so when we do the derivative, that's really a chain rule situation. So we have to multiply by the derivative of that y. And then we get this in our equation. This means derivative. So if I have a bunch of those in my equation, and I solve for those, it'll tell me dy over dx equals this, and then I know the derivative. So that's what our process is going to be. So you're taking the derivative of each variable, but when you take the derivative of y, you multiply by dy dx. So what's the derivative of x squared? 2x. I did not take the derivative of a y, so I do not multiply by dy dx. It is just 2x. What's the derivative of y squared? 2y. But I took the derivative of a y, so I multiplied by dy dx. And again, what does dy dx mean? It means derivative. So at the end, this is what I want by itself. I want it to say dy dx equals whatever. What's the derivative of 2y? 2, but I took the derivative of a y, so multiplied by dy dx. Derivative of negative 2x is negative 2. And what's the derivative of 8? 0. That's really easy to forget. Because you're just like derivative. Oh, that's just a number. I'm going to bring it down. But make sure you're taking the derivative of that number also. Alright, so that's, now I just have an algebra equation. My variable is this, and I want that by itself. I basically just want to isolate the dy over dx. And I'm going to describe that process, but it's not any different than solving a typical algebra equation. So I'm gather all dy dx on one side, move all other terms to other side. How many terms do I have on the left-hand side? 4, right? So I have this, 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 and this. The ones that have a dy dx are all on the left, so I'm just going to leave them there. And I'm going to take the 2 things that don't have a dy dx in them and move them to the other side. I would then end up with 2y times dy dx plus 2 times dy dx equals negative 2x plus 2. Because when I move those 2 things over, the signs would change, right? And now if I want dy dx by itself, and it's in those 2 spots, what can I do to like put it in one spot? Simplify how? I'm going to do like distributive property in reverse, basically, which is factoring. So I'm going to factor out a dy dx. If I factor, oh wait, so factor out a dy dx. So if I take a dy dx out, what's left on the inside there? 2y plus 2. And the other side is still just negative 2x plus 2. Some of you guys are going to love these because it's just like the same process over and over and over again. I hate them. But you what? Yeah, do you get bored? I probably shouldn't tell you I think it's boring. That's probably terrible teaching. Then, if I want dy dx by itself, what do I still have to do? Divide by 2y plus 2. So I'm going to divide by the stuff. It's high-level math terminology here. The stuff next to dy dx.
Why is it written
parentheses?
Why am I writing that?
Why is it written like that?
So it technically means the derivative of y with respect to x. So the equation is solved for y in terms of x. That's what that is getting at. You can technically, instead of writing dy dx, you can write y prime instead, because doesn't that also mean derivative?
Yeah, so much.
The problem with that is it's so similar to y or y to the first that you're going to get it. I'm afraid you're going to get it mixed up. I used to teach it that way, and there were just so many mistakes. Like, oh, I thought that was y to the first, but it was y prime. I think this is way more clear.
When do we ever say y to the first? Oh, we're simplifying.
You don't, but if you see this, you might be like, oh, that's y to the first. You know, I'm just telling you based on experience that people make mistakes on it. So anyway, I'm going to divide by the 2y plus 2, and I will end up with this, and that is my derivative. dy dx means derivative. I'm looking at that, it says the derivative equals this, and that's my derivative. Be careful when you're simplifying these. If you're going to simplify, and if it's free response, don't simplify. If it is multiple choice, you might have to match up with what they did. But be careful how you do it. If you're going to, how many terms are in that problem, in that answer? 4. If you're going to simplify, whatever you're taking out has to be in all 4 terms. Is there something here that's in all 4 terms?
Yes.
So I could make this one negative x plus 1 over y plus 1. You do not have to do that. That's just the multiple choice. Like, I got this. I think I would be able to match up if those are the same. But what happens a lot is I'll get like 2x plus xy over x plus 3. And people will be like, oh, I'm going to take an x out of all those. And you can't do that, right? Because you're taking an x from the 3 and there isn't one there. So just be really careful when you simplify. If you simplify. And then from here, I can ask you, like, the difference is, and we'll do more of this tomorrow, if I take a derivative normally and I want to plug in a number, you're only plugging in an x value, right? Usually your derivative will be like 2x plus 3, plug in an x value. Now if you're going to plug in, you need an x and a y value. So I'd be like, find the derivative at 2, 7, x, 7 for y, and do the same thing, but there's just two variables in it now instead of one. How's that process seem? It's not bad, right?
Way better than quotient product.
Yeah, it's a lot easier than that stuff. Now we haven't gotten to like the trickier ones yet, but it's still not that bad. Let me give you kind of a basic one like that. Product rule does go with this quite frequently, but it's still not that bad. So before we do product rule, though, let me have you do one without product rule. Try that one. And this is tougher than the one I gave you. Like it's a little bit of a level jump, but not too bad. Should we try it together, or you want to try it first? Okay. Yeah, I figured that. I'll get it later.
I see you have Z turned up the recycling.
I don't care. So the gathering is what's a little different, because you're going to have dy dx on both sides of this one.
You couldn't just move them.
Yeah, you just move them.
I mean, the 6y plus 2x, you could move it over.
Oh yeah, that'd actually be smarter. I'm going to go through without doing that, but yeah, that's cool. So I don't know if you guys heard what Caleb just said, but if you want to move everything to the left side before you do it, that might be easier. You could actually even combine those. I didn't even realize that. But you could do that too. If you go to the opposite side that I do, stop for a second. I got this answer, right? I want you to realize that this answer would be the exact same. This would be if I gathered all the dy dx on the left-hand side. This would be if I did it the other way, so if I just went to the other side of the equation. So if every single sign is opposite, it's the same. Does that make sense?
Yep.
Okay. What? Okay. Let's check. Am I good?
Yeah.
Go ahead.
Nice job.
Your gateway is going to be Monday and Wednesday. Because you won't have class Tuesday. The half day stuff. So we're doing this for 2 days. Maybe 2.5, like maybe part of Friday also. I'll give you a practice gateway on Friday. So you know like exactly what to expect. And then Monday and Wednesday. It takes 2 days, but you get 3 tries. Some of you will do 10 questions the first time, get them right, and you'll just have Wednesday off. Some of you will take 3 tries and it'll take you. So it just depends.
Will this be on?
Yes. The third. We'll do 3 attempts in 2 days. Over the span of 2 days, you'll get 3 attempts. So it's not 1 per day. You'll finish it. Yeah, so you'll come up, I'll check it while you're watching. I'll be like, you messed up here, here's why. You messed up here, here's why. Do you want to look at it for a minute? Sure. Come back up when you're ready for the next one. Nope. It's a grade. So I'm taking, it's a test. I'm taking your best score out of the 3 attempts. In college, when I described that to you, I just had to pass it. But I can't really, kick you out of the class if you don't pass it in high school. That doesn't really work very well. So I'm making it a grade.
So 3 attempts that we get have to be done within those 2 days.
Yes. And I mean, it probably takes like a half an hour. So, most people will take one the first day and kind of start the second one. And then the next day they'll finish the second one, and if they need the third one, they'll do that.
And so you will talk to us about what we did,
Yes.
how we did on the first one before
Yes.
we start the second one.
Yes. That's like in my opinion, the most valuable part.
Yes.
Letting that cheese stick just sit there.
It doesn't matter if you get another one. You did wrong in the first one.
Your cheese
Right.
stick, you just you need to get out there and get it.
So, what you did say also, you have to redo the entire test. It's not just one. And are they different versions, or is it like the same test?
Different versions, but the same.
Like, kind of.
Like if number one is you guys probably want to hear this too. He's saying like, will the three gateways be different, the same, or what? They're different versions, but they're similar in their setup. So like if number one is a question that involves product rule and trig, it'll be a question that involves product rule and trig on all three tests. They'll just be different numbers. That makes sense. Number two might be chain rule and LN, and then be chain rule and LN on all three tests. Okay, so stop me if you see I'm doing something you don't understand. 2x minus 3y squared, and then I took the derivative of a y, so dy dx. Plus 8x to the third minus 4 times dy dx. I'm shook. 6 times dy dx minus 2. I'm going to bring all the things that have dy dx and then to the left, but everything else on the right. Is that the side you guys mostly did?
No.
You did the opposite. If you did the opposite, remember your answers will all be just opposite of mine. So I'm going to go over here and go negative 3y squared dy dx. Negative 4 dy dx. This comes over, so it's negative 6 dy dx. At which point I can combine those, and I'll do that in the next step. This 2x I'm kicking over here. This 8x to the third I'm kicking over here. The minus 2 was over there. At this point, I went a little fast there. I'm taking the dy dx out of everything. If I do that, I'm left with negative 3y squared minus 4 minus 6, so the minus 4 minus 6 just combines to be minus 10. Is that okay? I do that too fast, or we good?
How did you do negative 4 minus 6? I don't get that math.
Are you helping the cause, or are you hurting the cause right now?
Hurting.
Yeah. And then divide by what's next to the dy dx. You should have that. Is there anything I can take out of, how many terms are there? 5. Is there anything that's in common in all 5? No. Okay, so yeah, that's why, like, if you have the opposite of everything, you're good. So if you have 2x plus 8x to the third plus 2 over 3y squared plus 10, those are identical answers. You can have either one. Isn't the third supposed to be in front of you?
Yeah.
That's just for aesthetics. It doesn't matter. In this case, not every time.
Well, no, I know.
Yeah. So if you move the dy dx to the right, you've got this. And if you kept the dy dx to the left, you got this. Do you want me to show you why they're the same, or do you believe? Doesn't matter. Basically, I could factor out a negative 1 from the top and the bottom, and then they would cancel. You'd end up in the same spot. Yeah.
Couldn't you just move before you start any of the derivatives all the y's to one side and all the x's to another?
Yeah, remember when you said that before, and I told the class that?
No, I asked if you could move everything to the side. I didn't know if it still worked. If everything was on opposite sides.
You say put all the y's on one side, all the x's on the other side?
Yeah.
You could do that, yeah. It's so this problem probably wouldn't be on the AP test. It's not like hard enough. The AP test will give you these with product rules. Let's go. I'm sorry. Back to
I
you.
should ask you a question, like, if we had like a free response question.
Yeah.
How specific and how much work and everything you have to show?
That.
But if you
No, I'm sorry, not that. You can see it. You got to show this step.
I can see
None of us can see that step. So
I mean, it was like that, so don't pretend you couldn't see it at all. So you got to show that stuff, because that's like the stuff that you're proving, okay, I took the derivative. But I think some of you guys will get to the point where you can jump from there to there.
Yeah.
Because anything that has a dy dx next to it, so this and this and this, where's that going to end up at the end? On the bottom of the fraction. Anything that doesn't ends up on the top. So you can skip that. I don't know. It's up to you. Like, you got to practice that for yourself.
But like crossing things
I
out.
am freaking talking. You do this every day. Don't interrupt me. Stop. Like, you asked a question. I was answering it. You just... I don't even know what I was saying. I don't know what I was saying. What was your question that was so important?
I was just thinking, if you like cross things off or like stuff like that, would that be okay on the test to a
If you show this stuff and then start crossing stuff, it's okay. Other questions? Okay. So product rule. So they'll give you, most likely, this is more like what you'd see. Let's say x squared plus 2x squared y plus x squared y squared equals 8. And the reason like what I was saying to you is you can't really move the x's to one side and the y's to one side in this scenario. So yes, that would work. It's probably not going to be what usually happens. You know what I mean? Alright, so 2x squared is easy. Derivative of x squared is 2x. Plus, and then I would look at, this is product rule, because you have a variable times a variable. So I would look at 2x squared as like your first thing, and y as your second thing. So then product rule is 2d1 plus 1d2, right? So the second thing is y. What's the derivative of the first thing? 4x. Have I taken the derivative of a y at this point? I have. I rewrote the y. Took the derivative of an x. I didn't take the derivative of y yet. Plus 1, so 2x squared. What's the derivative of y? 1. But you took the derivative of y, so multiply by dy dx. So the derivative of y is basically just dy dx. Which is really the whole point. The derivative of y is dy dx, so I'm trying to find the derivative of y by finding dy dx. Plus, second thing, so y squared times the derivative of the first thing plus the first thing times the derivative of the second thing. What's the derivative of y squared? 2y, and then times dy dx, right? You guys with me? Nobody's saying anything, so I can't really tell. What? You good? Equals what? 0. This is what I mean. My guess, and I don't even know, you might be able to do it now, but I think within like doing 3 or 4 more of these, almost everyone would be able to go from that to the answer. You are allowed to do that. But, this is what I said before. You need to check for yourself if you can do that. If you're trying to skip steps and you're getting wrong answers, you shouldn't be skipping steps. If you're skipping steps and getting the right answer, great. But so where would this end up in my answer? Top, and it would be negative. This would end up top and negative. This would end up bottom and positive. Top and negative, right? Bottom and positive. You see what I'm doing to get that? So you're welcome to take that skip step. You're welcome to not. I'm just kind of showing you, if you're on the AP test and you're in a time crunch, this is something maybe you could use. But I'm not going to do it on this one. I'm going to go through the process. So I'm taking everything with the dy dx and just leaving it on this side. Moving everything else over. I left these two in a way that that drives me crazy. But it's not wrong to leave it like that. I would really prefer that as 4xy. I'm just so used to number then x then y. I wrote it like that so you can see that that's acceptable. But I'm probably going to just change it to 4xy in the next step. And then same thing here. I would want 2xy squared. But it's not wrong to write it y squared 2x. That's why I left it there so you can see. And I think we can almost definitely skip this next step, right? What is happening?
It froze.
But I didn't. Okay. So I'm going to take the dy dx out. What will be left is 2x squared plus 2x squared y. This step, I think, as you're going, will start to feel like a waste of your time. But only if you're getting them right. And then, you divide by that stuff. And we get there. Now, in a free response, leave it. On a multiple choice, there are things we can cancel out of all the terms. There's 5 terms, right? What can I take out of each term?
2s.
2x. There's a 2 and an x I can get rid of. So this screws some people up too. If I take a 2x away from a 2x, what's left? A 1. There has to be